We've got a quarter circle, and nestled inside it are two semicircles, each with a diameter of 8 units, and these semicircles overlap, creating two shaded blue regions. Our mission is to find the total blue area. Now, the whole problem hinges on one key insight. Instead of calculating each blue shape separately, we're going to show they're connected in a surprisingly elegant way. Let's start with what we know. First, the quarter circle. The radius is 8, so a full circle would have an area of pi times 8 squared, which would be 64 pi, but we only have a quarter of it, so we can divide that by 4, to get the area of the quarter circle, which is 16 pi. Now for the semicircles, each has a radius of 4 units, and a full circle with a radius of 4 has an area of pi times 4 squared, which equals 16 pi. Half of that for one semicircle would be 8 pi, but as there are two, then that's 8 pi plus 8 pi, which equals 16 pi for both. And here's our first, wait, what? Moment. The quarter circle is 16 pi, and the two semicircles combined also equal 16 pi. They match perfectly. Keep that in your back pocket. It's about to matter. So let's break the quarter circle into 4 distinct regions. 1. The lens-shaped overlap where both semicircles meet. 2. The part inside the left semicircle. 3. The part inside the bottom semicircle. And 4. The crescent in the top right corner, inside the quarter circle but outside both semicircles. So our total blue area is the lens overlap plus the outer crescent. Now, here's where it gets beautiful. Since the quarter circle and the combined semicircles have the same area, something has to balance out. The extra area created by the overlap must exactly equal the area in the outer crescent. In other words, the crescent equals the lens. So, as both blue regions are identical in area, then the total blue area must equal 2 times the overlap. We don't need to wrestle with two complicated shapes. We just need to find the overlap once, then double it, and we're done. Now let's zoom in to the overlapping semicircles. The overlap lens is actually made up of 2 identical circular segments, one from each semicircle, so we'll find one segment and double it. First, we need the sector angle, and if we look at the left semicircle, its center sits 4 units directly above the bottom left corner, and the overlap touches 2 points, the corner itself, and the center point at 4, 4. Now from the semicircle's center, one radius points straight down, and the other points straight right. That's a 90-degree angle. So we have a 90-degree sector of a radius 4 circle. So to calculate the quarter circle sector, we divide 90 degrees by 360 degrees, then times by pi r squared. So 90 divided by 360 is 1/4. Then pi times 4 squared is 16 pi. And a quarter of 16 gives us an area of 4 pi. Now the triangle inside of that sector is a right triangle with legs of 4 and 4. So that can be calculated with 1/2 times base times height, which is 1/2 times 4 times 4, and that gives us 8. So one segment area is just 4 pi minus 8. And the whole overlap lens has 2 of those segments, so the overlap area is 2 times 4 pi minus 8, which gives us 8 pi minus 16, and that's the area of the lens. And remember, the total blue area is twice the overlap, so that would be 16 pi minus 32. And if we popped that into a calculator, we get approximately 50.27 minus 32, which gives us 18.27. And there it is. The total blue area is 16 pi minus 32, or approximately 18.27 square units. Please like and subscribe, and I'll see you in the next one.